we've got a good group. Oh, we've still got some people joining here. Stephanie, I'm going to let you take over. I'm getting some. Like I said, I'd really like to use this whole hour and got lots of fun stuff to share. So thanks for joining us tonight for the Nebraska Math Teachers Circle, especially the week after winter break. I know you are all so dedicated to be here after, I'm sure, a week that's been a little crazy is coming back. And so it's so wonderful to have all of you a part of tonight's session. My name's Susie Katt, and I am currently the K-2 Mathematics Coordinator for Lincoln Public Schools in Lincoln, Nebraska. And together tonight, we're going to dive in a little bit deeper about this idea of productive struggle in mathematics. While this presentation is mainly geared towards elementary classrooms, the book was written for a wider audience. And so I noticed on the registration list, we have some pre-K teachers through 7th grade teachers joining us. So as we go through this presentation, I'm going to give some examples, but you might think about how certain activities or ideas might be adapted for your respective grade level. This is going to be more of a presentation style rather than a let's get, roll up our sleeves and do some math together, just because there's so much stuff I'd like to share. But you'll engage by reflecting on your own or on the 6 actions and making connections to your own work. So I want to let you know up front, I have a tendency to talk fast, and I planned a lot for today. So I'm going to keep this at a pretty brisk pace. I also, just like I said, I want to make sure to cover all 6 actions related to productive struggle that are in the book. And I only have about an hour to accomplish this. So it is going to be fast and furious. So thanks for understanding in advance. If you do have a question, we would ask that you put it in the chat. Stephanie Vendetti from the center is going to take note of those. And at the end, then we can sure address any questions that you might have. All right. So what I'd like to ask that you do is, in the chat, if you wouldn't mind sharing 3 words that, or you could just do, you don't have to do up to 3, but up to 3 words that you generally associate with struggle. So real quick, just the first question or first word that comes to mind when you hear the word struggle. What word comes to mind? Frustration, challenge, shutdown, hard. Frustration, hard, can't. Frustration, too hard. Oh my gosh, it's going so fast. Questioning, defeated, hard, too hard. Give up. These are all difficult, challenging, support. That's a good one. Productive. So we'll talk about how to make productive, but most often when we think of struggle, we think of words to describe struggle through emotions that we see in these pictures, right? Frustration, loss of hope, anger, they're challenging, disencouragement, really maybe annoyance. And often we approach this idea of struggle in our classrooms with this mindset of this is what happens when kids struggle. However, when we ask elementary students about struggle, they often see it in a very different way. They relate struggle to a context or life event such as learning to tie your shoes. So here is what some young students recently said about struggle when they were asked, what do you think of when you think of the word struggle? While one shared it can be frustrating and hard, overall, they have pretty positive view of struggle. They have experienced struggle when they were learning something and understand that struggle is a natural part of learning. As teachers, then we need to capitalize on this and provide our students with a foundation that will help them navigate the many different struggles they encounter as they grow and develop. These struggles will be both in learning math and throughout all the other aspects in their lives. So NCTM reminds us that struggle is an important part of learning mathematics. Struggle is an opportunity to delve more deeply into understanding the mathematical structure instead of simply seeking correct solutions. We need to reinforce this idea that learning math is working to understand, not just completing a task. So as I started thinking about this whole idea of productive struggle with 2 colleagues, we realized our experiences really influenced how we dealt with struggle in our classrooms. As a young student, I was taught not to ask questions, but just to follow the way my teacher solved the problems. Or I was given tricks, One I remember clearly is, and you probably do too, is don't ask why, just invert and multiply. So when I was in college, the focus of my math methods was on the content I was going to teach. I was taught to create lessons that scaffolded learning so students wouldn't encounter struggle. I thought about the step-by-step procedures that I would teach. Often, when a student would struggle, I'd view that as a problem with my teaching that I needed to fix. I vividly remember getting observed for my tenure evaluation, and the follow-up conversation was what to do to help students not experience struggle with two-digit subtraction. We talked about the procedures I wanted to make sure to get through to my students. I also thought struggle just happened, one of those teachable moments per se. I didn't feel as if I had control over when struggle would occur. So as I started thinking more about this idea of struggle, I adopted the idea of growth versus fixed mindset. I know that came up in the chat. I hung that poster of the cat in the tree that said, hang in there, and I thought I was good and ready to go. Well, needless to say, that didn't work so well. And I've learned so much more about struggle, and that is an important piece of math instruction. In thinking about this, and colleagues and I have identified 6 actions that teachers can take to evoke struggle, as I've come to realize it is very critical to learning. So tonight, we're going to get a brief introduction into these 6 actions, and I'm going to share a few practical examples of how these might play out in a classroom. And so, as I've mentioned, as teachers of elementary students, we play a critical role in how students build a foundation in embracing struggle so they can learn mathematics. So here we go. So the first action is to value struggle. So we tend to value struggle, like I said before, in learning experiences outside of school, like swimming, or learning to ride a bike, or if you've ever taught a teenager to drive, most likely you've experienced struggle in big ways. Not very fun. But it is most important that we embrace the same value for struggle when teaching mathematics. It is a necessary component of learning mathematics with understanding. When we capitalize on productive struggle, it leads to long-term benefits. Our students will be in an advantage when they understand struggle is a good thing, and is an essential part of learning new things. So if we help them learn to embrace struggle, develop some ways of navigating struggle, and continue to foster this, our students won't really know any different as they progress through their formal schooling years. So we need to help students realize that math isn't just about getting the right answer or doing it the teacher's way. As teachers, we teach many lessons, and helping our young kids realize that struggle is productive and useful is one of those lessons. And as we've discussed, this will help them outside of the classroom as well, in sports, when they enter the workforce, parenting, and many other aspects of their lives. It is important to note that every student is worthy of struggle. So we might all agree that productive struggle is important, but why does this matter? Well, traditionally, our instruction in mathematics classrooms has not been characterized as promoting productive struggle. Studies have shown that instruction in the US often falls short of asking students to think or to reason. We tend to proceduralize mathematics and or teach tricks or shortcuts so students can be successful. We do all this as if students become frustrated. We do this as students become frustrated or can't complete a task, we take this personally as our instruction is of the highest quality and we didn't do a good job or isn't of the highest quality. We love our kiddos to death, and that's why we often become teachers in the first place, right? So therefore, it just kills us to see them encountering challenges. So often we put on our superhero capes and we swoop in to rescue them. So we don't want to see our kids frustrated or not know what to do next, so we swoop in with these strategies. We do things to help students get to the right answer or solution. So let's talk about these here. So first, we might break down the task. We might ask guiding questions that drill down to the answer or provide step-by-step directions. We might reduce the cognitive demand of the task by providing hints or removing the rigor. Sometimes we even take the pencil or the manipulative out of their students' hands and do it for them. I have been guilty of this on many, many occasions. We took away the opportunity for students to make sense of mathematics when we do these things. So it's important to note that these strategies are very well intended, as we all want to see our students succeed, and we hate to see them in a state of uneasiness or ultimate frustration. Often, before they get to this point, we'd rescue to avoid seeing them in this way. So instead of defaulting to rescuing answers, we should turn our attention more to rescuing student thinking. We can model how they might work through a problem by providing some guidance of what the students might think about. I'm going to ask these questions, such as the two listed on the slide. We invite students to pause and process, and it refocuses their thinking. Asking questions to get students to think about their own thinking is important, as this isn't something our students tend to do on their own. It also will enable transfer onto other situations and create student agency or a voice and choice in how they learn. So there are teacher behaviors we should keep in mind, as these are strong indication of the health and well-being of struggle in a classroom. Knowing these teacher behaviors is important, as there's a cause and effect relationship between teacher and student behaviors. The way students do or do not struggle is profoundly influenced by a teacher's actions. For productive struggle to be most effective, teachers must know the strengths their students bring, reinforce a positive learning community, select or modify tasks which will provoke struggle, consider how students might react to struggle. Take temperature checks often to gauge what is to happen in relation to struggle. Reinforce strategies students can draw upon as they encounter struggle. We must debrief struggle and talk about what's worked and what didn't, and reflect upon how our students and ourselves reacted to struggle. The student behaviors indicate what's going well relative to struggle and what needs to be developed. So looking for these behaviors can help you take stock in the frequency and ongoing development of productive struggle within your students. It can help you reflect on your practice and math ecosystem. Productive struggle is evident when students believe they are an important part of the mathematical community, they see themselves as mathematicians, and they engage in tasks, respect others' ideas and thoughts, and know when to ask questions. So we also want students to begin to understand when to ask a question, attempt to navigate struggle on their own without our teacher guidance or support, reflect on their learning, and come to realize making mistakes is a good thing when learning mathematics. Some of these will grow with time. For example, a really young student might not know what question to ask, but they can realize asking questions is an okay thing to do. So armed with knowledge of and value of productive struggle, teachers are better able to counter unproductive beliefs that can interfere with learning and productive struggle. Being aware of these will be useful as you may engage in conversation with other teachers, your staff members, parents, and or community members. It's important that these shifts occur to create community where productive struggle is valued and embraced by all. So we want to move from thinking struggle takes too much time to embracing the idea that struggle makes learning stick. We also want our students to understand that faster isn't better. Many students believe this to be true when they enter school, and we often unintentionally reinforce this message through our own actions. So rather, we want them to realize people who are good at math, and often do, struggle with different mathematical ideas. So now that we've looked at the first action of value, we can move to the action number 2, which is foster identity. So I encourage you to think about these questions. Your identity shapes your math teaching and how you relate to productive struggle. Asking questions like these of ourselves will help us gain a deeper understanding of our own math identities and how this impacts the actions we make as teachers. Oh, let's see. Oh, sorry. So mathematics identity is the disposition and deeply held belief that people develop about their ability to participate and perform effectively in mathematics. So we know that each and every one of our students is really unique. Even our young children have math identities shaped by a rich and complex set of attitudes and experiences. And these identities change over time. So we can't fully learn about our students' math identities through one single activity. It's important we engage in activities throughout the year. This will also help to see how our identities of our students evolve. If it's our goal to get to know our students so that we can better engage them, better support them, and to foster thinking and productive struggle, we must find ways to learn about who they are as learners of mathematics. So here's one activity for uncovering students' math identities, and it's a popular one, the math emojis. So asking students to create an emoji to describe their feelings will give us a window into their students' feelings. I've led a couple of classes of second graders just recently through this activity, and I thought I would share some of their responses. But before I do so, I wanted to show how I introduced this activity. First, I displayed a series of 3 emojis to explain how I felt when anticipating and completing a big project. It was my dissertation. So showed them how I went through and asked them what they thought I was feeling in each stage. Then I showed this image and asked, when you think of math, which of these emojis would you choose and why? And I gave them a gentle reminder that mathematicians always tell why. So here's a sampling of what I came up with. And I know it's a little hard to see. The student on the right or the left corner said she felt happy because math was fun. The middle is the boy gets stressed in math because it's sometimes hard. And it was really interesting as the coloring of his picture depicts those feelings. Another student in the bottom right-hand corner said she feels sad and scared because math is hard sometimes. This information was very informative for the teachers of these students, as math doesn't come easy for the little girl who said she was happy about math, and the stressed student is always one that has his hand raised to share about his thinking in front of the group. One teacher commented, "This isn't what I would have predicted." So here's some other responses. The little boy on the left said he was nervous as he doesn't know what they are going to learn and what numbers are going to come up. The boy on the right, the picture on the right, was from a boy who said he gets mad when he thinks about math. I asked him, I said, well, why do you get mad? And he says, because counting those big numbers, it takes a really long time. When I use my fingers get really tired. And I had to keep my smile, try to not smile because I just thought it was a great response. But it was so informative as these teachers were really, and these teachers that in these classrooms were really appreciative of this information, as they felt that these explanations gave them insight into the types of behaviors they saw from their students in mathematics. It's a great way to help students expose their feelings. So then the conversations that concluded these activities were really powerful. We all feel different in math sometimes, and it's sometimes okay to feel sad and frustrated, but we can offer help or be a good math friend. And it's okay that not all of us feel the same way about math all the time. Older students enjoy this activity as well. They can draw multiple emojis. These were drawn in response to the prompts when I think about math and when I am encountering struggle. Like I said, it may be really interesting to see how these emojis grow over time or how they change over time and ask students to repeat this activity throughout the year. Another way to uncover students' math identities by giving them a prompt and have students share orally. I like to do math when, or this could be done publicly, or they could whisper it in your ear as they line up for recess or get ready for lunch. Something for them to think about and for you to learn about them a little bit more as math learners. Another way to get to know your students is through a learning journal. You might provide a prompt. Our youngest students will most likely draw a picture, but then they can start to add words to talk about what they're thinking and want to share and communicate. As students become more accustomed to communicating their thoughts through writing, they might add some words, and they might even use this as a family assignment. Older students are more proficient with writing, so they can respond with prompts and elaborate on their ideas. So here's some questions that they might use. So do you know what your students think they're good at? This math superhero activity is a great one to learn about what strengths your math learners see in themselves. Lily, on the left, likes to show her thinking on paper and learns from her mistakes. Will, on the right-hand side of the page, likes figuring out problems by himself, even hard ones. So displaying these kind of pictures in a classroom or in the hallway sends a message that we all have strengths in math, and that these may be a little more appropriate for young learners, while some kind of a display like this might be more relevant for older learners. Strength-based instruction, and by the way, if you haven't read it, there's a great book by Karen Karp and Beth Cobbett. It reminds us to capitalize on student strengths in mathematics classrooms. So this is a nice way to do that and get to know more about your learners as a result. And most likely you will learn about what they think about when they struggle, or what strengths they have that they feel that they can use when they encounter struggle. So we know kids love stickers, whether they put them on their notebooks, Hydro Flask, or anywhere else. Some have students create a sticker that tells about what they're good at for math. These displays can then be on their math journal, their desk, or their class bulletin board as a reminder for them, as well as you learning about them, what they feel about themselves. So surveys or short interviews are another way to gather interesting information about students. This could be done on an individual basis or a whole group by asking one question. Students can use a scale. They could use their fingers, 1, 2, or 3. They could do it kind of publicly. They could put those, their numbers in front of their heart so only you could see their responses. Or they could even draw a smiley or frowny face on a whiteboard or on a piece of paper. Doing this multiple times throughout the year will provide greater insight in how your students view themselves and what they think about mathematics. So lots of other activities that can be adapted for mathematics and this whole idea of identity. The important thing here is that you have a collection of activities, and use these over time. They shouldn't take a long time. Most of these are brief. I think the emoji activity took us about 15, 20 minutes, but they have the potential to provide very useful information. So also be on the lookout for messages that you might not anticipate. Like this one student wrote on the top of his paper, he was working with 3-digit number representations, and he wrote, "I can do it. I can't do it, but I'll try. I got this." The teacher who shared this with me said she loved seeing this, as she knew this content was challenging for the student, but knew that the student wouldn't give up. All right, so now we're on to action 3, which is building community. So we know a community is a collection of identities, and these identities can work together or against each other. Things we know about a community in a classroom. We need to be intentional in building and maintaining it. It doesn't happen magically or by itself. A community can have a common understanding even though students don't have the exact same experiences. We need to establish norms for productive struggle in our mathematics communities. We can craft these as a group, reinforce them through our actions, and update or revise them as needed. So a community shares a common purpose, values each member, and is built upon norms and holding each other accountable. Most often, we have rules in our classrooms, but do we have rules or norms about what we value when learning mathematics? Something to think about. What would norms that support productive struggle sound like? So, we often have, like I said, those general rules such as this poster. Time well spent to talk about these. Time is well spent when we talk about these things in relation to mathematics. So how do we work with a partner? How do we share ideas? How do we take risks? Is it okay? It's not just a one sentence or one conversation topic. This is something we need to revisit often. And I would argue the younger the learners, the more often we need to probably revisit it as well. So one thing that's helpful to do is to make a what it is and what it isn't chart. This is one about taking risk or trying something new in math. This was built with students as they need to contribute to the ideas. So giving a context is helpful. So a personal stories that you can share makes this seem okay. Common agreements are a part of a healthy community where productive struggle is valued. This is an idea I borrowed from a first grade teacher. Over the first month of school, she establishes some norms for learning mathematics, but she kind of infuses them into her routines And then she highlights them when they surface during conversation or when she notices and finds evidence of them. Then, after about a month or so into school, she says, "What have we learned that good mathematicians do?" The class generated a list and she took pictures of her students modeling these behaviors. So each day before then mathematics starts, a student leader leads the class through this pledge. Today we will. And I wish you could hear him replicate it because it just has this little rhythm and rhyme to it and it's just so sweet. But some of the things that are on this daily math pledge are help each other, ask questions, think, learn from our mistakes, and use lots of strategies. Often students will refer back to these pictures. It provides a way for the teacher to reinforce these norms as well. Often she just points or asks students, which one could you try? The same activity could be replicated for older students. However, they might keep their math pledge in a folder or a notebook as shown here. Students could recite the pledge together, read it on their own, or discuss it with a partner. The important thing is that these common agreements about mathematical community are revisited often and revised when necessary. Another way to build community is to have intentional discussions about struggle. Pictures such as these evoke great conversations. In a classroom of younger learners, I facilitated a conversation of what struggle meant recently. Then I asked some students to pick out a picture they felt best represented struggle to them. So I led with this sentence starter. I think struggle is like blank because, and asked the students to use it to frame their thinking. So here's some responses in response to those pictures. The picture, I think struggle is like the picture of the boy lifting the weight because I got stuck on something in first grade when I was learning something new. I struggled a lot. Or I think struggle is like the ducks because I worked hard to understand equations and my teacher was there to help me. And then this one was one of my favorites. I think struggle is like the birds because I get hungry when I do math. Of course, a pure, you never can expect what will come out of young kids' mouths. But of course, I had to follow up and said, so what is your favorite math snack? And of course, it was chocolate. And we had to agree on that. So this one was really interesting to me. I wanted to share this and how deeply even young students can think about struggle. So in Lincoln right now, we have Zoomies and Roomies. Our Zoomies are attending school through Zoom, and our Roomies are those students that are in person. And one of the Zoomies said, I think struggle is like the picture of the birds because it reminds me of nature and stuff. And of course, I was really, perplexed and thinking, how does this remind her of struggle? And so my response to her was, well, can you tell me more about what makes you think about nature when you think about struggle? And her response was, it makes me calm and I can get back to learning. Wow. I was kind of blown away. So our students can come up with, really deep ideas and things and strategies that they use for when they encounter struggle. And I know our older students will come up with even more wiser responses. We just have to give our students opportunities to think and talk, and they're going to come up with some amazing things. There's lots of ways to get mileage out of this activity. It supports students' language related to struggle, and it also helps young students see that how different students view and cope with struggle. This activity is a great one to revisit. It can be a four corners activity. I know in COVID times that makes it a little difficult, but maybe if you have enough space, or you could just have them kind of point or indicate in a different way. But students would go to the corner or indicate the picture that shows how they struggled today in math. Pictures around the room or possibly the building serve as visual reminders that struggle is a good thing and a natural part of learning. And to personalize these stories, share your personal accounts of struggle, like taking a class in college or writing a big paper project or learning how to sew or cook. If you're old enough, you might even relate to the picture in the bottom right-hand corner of trying to get a cassette tape unraveled from your boombox. I know that's telling my age, but that was a big struggle when I was young. So the same pictures can be used for reflection. We'll talk about this in just a little bit. So now we're on to action 4. Can we plan for struggle? And if so, what do we have to consider? So here's some questions that we might ask ourselves. Is struggle out of our control? Is it something we react to? Is it something we provoke? I'll be honest, when I first started teaching, I'd say struggle just happened, and I couldn't anticipate when it would or why it did. But now my thinking's changed a little bit. I'd suggest that you can plan for struggle. So, this planning, of course, incorporates the goal of the lesson, the tasks and the instructional moves to develop understanding, and assesses if students have met the intended outcome. But planning for struggle incorporates other considerations into the process by taking into account what students might do, what they might struggle with, and what we can do in response. It helps us be better prepared to respond and support struggle intentionally, which we'll talk about in a little bit in Action 5. So it's possible that planning templates you use already incorporate these ideas. If not, any formal planning tool can be modified to account for other considerations. So here's one example from Howard County Public Schools in Maryland. It's a district-wide lesson plan tool grounded in the understanding by design. To incorporate student planning tenets of task selection, anticipation, and prepared response questions. But a formal planning tool isn't necessary. A simple organizer shown here can hold the same potential. It can easily be replicated by folding a piece of paper, in eighths or fourths, and capturing the big ideas of anticipated strategies students might use, possible misconceptions, and potential questions and responses related to these. An important piece of this planning process is the task selection. So these have many names. You might have heard them as good tasks, rich tasks, worthwhile tasks, or whatever we call them. They hold great potential for advancing student understanding. So this image, based on research, indicates that task quality may be one of the most important component of teaching mathematics. A high quality task and high implementation of the task, there will be high results in relation to student learning. This is shown as in the bottom row in green. But notice the salmon color or the red at the top. The results for a low task, even with good teaching, reveals that great teaching doesn't overcome bad tasks because results are going to be low. Even though you did some wonderful teaching, if the task quality is low, the results of student learning are going to be low. So having a high quality task matters for students to experience struggle. So just a quick note, Teachers Pay Teachers or Pinterest isn't the place to find these high quality tasks. In a study of a quality task found on these sites, less than 1% were called doing mathematics or tasks that we'd say fall in the high quality, high implementation category. So what makes a task high quality? It aligns with content standards for the grade level. It encourages the use of different representations. It involves students in an inquiry-oriented or exploratory approach. And it allows entry into the mathematics, kind of that low floor, high ceiling that you might have heard about. Connects to prior knowledge. Invites multiple solution approaches and strategies. Engages students in explaining what the answer means, and is relevant and interesting for the student. The context draws them in. So there are tools out there that help us identify high quality tasks. This particular one comes from the Mind the Gap series by John Sangiovanni. I'm sharing it as a rating tool such as this often helps someone get started in deciding if a task is of high quality or low quality. And after time, it just becomes a little more automatic. You wouldn't necessarily need to use such rating tool every time, but this will help get you started if you're not familiar with those. So often tasks you currently use or have access to can be modified just slightly to become better tasks. So let's look at these two. The task on the left is one we typically see in curriculums or in maybe the things we use in our classrooms. Students here in task A are asked to fill in the blanks. Conversely, the task on the right is one that's been, like I like to be called, tweaked just a little bit. It's not a major overhaul, but changed just slightly. The task has been modified a bit to raise the rigor, and now there's an opportunity for struggle when presented in the appropriate way. As teachers, we can modify as teachers, we already modify all sorts of things like the rules to a game. We change the name in a word problem to make it include a student of our own, and we restructure lessons to increase engagement. So one of the most important modifications we can make as teachers is to change mathematical tasks to that better promote struggle. Modification for modification's sake is just not the goal, but we need to be purposeful to the struggle we are asking students to engage in. So let's look at some different ways we can modify tasks. There's a number of different approaches. We'll go through these rather quickly. However, by seeing different examples, it might spark your thoughts of ways you can modify a task that you might not have done in the past. The task on the left is very typical. Fill in the missing addend. The task on the right is asking students to go beyond a single answer. Students are to create the question for a solution of 10 fish. Another example of using the create modification for older students is shown here. The task on the left asks students to shade 6/10. It's basically a count and color type of tasks. The task on the right asks students to show 6/10 in 3 different ways. This asks students to apply their understanding of place value and share their reasoning. Strategies, properties, and other mathematics concepts are generalizable when they are always true. For example, the commutative property is always true. It doesn't matter the order of the addends, as the total will always be the same. The task on the right asks students to connect equations that are equal. Not as much thinking or reasoning involved as the task on the right. Max says 3 plus 5 is the same as 5 plus 3. Does this always work? Students don't have to provide elaborate reasons why, or younger students. Those reasoning that explanation will get a little more elaborate as kids get older, but they can start to communicate their thinking about ideas through pictures and numbers in the beginning, and then again, those will become more complex as time goes on. So changing the situation is a way to modify tasks. So rather than asking a preschool or a kindergarten student to count 4 elephants and write the number 4, perhaps we could reverse the task. We could ask our students, how else could you show or represent 4? They might show 4 with circles, fingers, toes, with 2 plus 2, cubes, or many other ways. Here's an example of students being asked to complete the pattern on the left. If we reverse it, we ask students to come up with a problem that yields the given solution. So here we ask students to create their own patterns that count by 1s, 5s, and 10s. And we ask students to begin patterns in unconventional numbers, such as 42, rather than always starting at 0. Understanding of fractions as numbers and points on a number line is foundational for computation with fractions. We often draw a number line and have students identify a point that with a number line that is simply divided by the denominator as shown in the red box. The green box shows 3/4 on a different number lines, but asks students to determine the endpoint for each number line. Asking students if they agree or disagree isn't a new idea. Many of you probably use that. So the modification here is that a task is completed and that the students are asked if they agree or disagree with what is offered. The task on the left is simple. Color the shape task. The task on the right incorporates if they agree or disagree with a given solution. To begin, students may just show a thumbs up or thumbs down, and then over time can start to provide more reasoning about or the why behind their thinking. So here's another agree, disagree task for older elementary students. The task on the left becomes another color and count activity, which may not necessarily lead to a greater understanding of fractions. The task on the right has students dive into the fractional parts and reason why 1/4 and 3/4 are both correct answers. Another variation of agree or disagree is to show a mistake. Here, students are asked to tell if they agree or disagree with Carrie's work. Young students and older students can engage in a conversation about what they might do to coach Carrie to the correct answer once they determine they disagree. One modification strategy is to create higher quality tasks is to open it up. While the closed problems call for a single solution, like shown in the red box, The task on the right in the green box makes them effective vehicles for promotive productive struggle. And then here's another example of how to open up a task. Instead of identifying how students would solve the problem as in the red, the students are given more liberty to solve the problem in a way that makes sense to them. Just by removing the by place value, productive struggle is provoked and students can apply their own thinking. So compare and contrast is a great task. The task on the right could easily turn into just count the blocks and write the numbers below exercise. However, the task on the right encourages students to find similarities and or differences in the way 52 is composed. Another example of compare and contrast, maybe for older students, is this type of task encourages students to think about relationships between numbers. How are these numbers the same and how are they different? So the last modification strategy is a change of focus. The task on the right is a simple computation task. Ask students to subtract. The task on the right provokes productive struggle, as students are to think more about the mathematics and turns the focus from computation to thinking about the difference between two given numbers. So it's important to note that good tasks don't have to be complicated. Often subtle tweaks or modifications and how the task is implemented. Rather than make 37 with base 10 blocks, the students can be flexible and show it different ways. Here's another example of a good task. Prove why 5/8 has to be greater than 1/2 and why 5/12 has to be less than 1/2. And another, having students create and test different perimeters is a much different than finding the perimeter of one shape. This would be more of a middle school task with a shape with multiple sides in where asking them to take the pattern blocks and create different shapes to find the largest and smallest perimeter is a much more rich task that will promote struggle. So just a reminder, the planning is the essential piece in the implementation of the task. So once a task is selected, do it yourself so you can anticipate the strategies and misconceptions that your students might encounter. This comes from Smith and Stein's work that some of you may be familiar with. So once we've anticipated what students might do and what mistakes might surface, then you can plan on how you might react to these situations of struggle. So here's an example of this type of planning. It's not complex or complicated, but it's important for the process of planning for struggle. You might talk about the strategy students will use, the misconceptions, maybe the questions you might ask in terms of those strategies and misconceptions in response. So as you select tasks and modify them if needed, because some tasks won't need to be altered because they're really good just as they are, we must consider these things. There are two sides to the struggle equation, the task itself and the students who are engaging with it. This means that we also keep our students' identities in mind as well as they're working on these tasks. We have to keep also in mind the students' experiences with similar tasks. We have to understand and think about the understanding of the prerequisite mathematical concepts and the students' comfort with taking risks and trying new strategies and other things. Lots of things to think about as we plan for instruction. So another thing to think about is how we implement these tasks during lessons. So there's a very common structure that's shown on the left. The teacher models the task, the class does the task with the teacher, and then the students work on their own. This is most often referred to as a gradual release or direct instruction, and it can inhibit or perhaps sometimes eliminate opportunities for productive struggle. This controls the learning sequence to minimize student misunderstanding and can frame learning to be the act of telling a student what to do. We can think of this as the way many of us experience mathematics ourselves as learners. However, I encourage us to think about if we tweak this instructional model a little more often, rather to replicate what the teacher does, we want students to engage in critical thinking about the mathematics. The instructional model on the right shows this. The teacher launches the task, the students engage in the task, and then the class debriefs. One might think of this as turning the other model upside down. This may be, oh, excuse me, I got a little ahead of myself. This may be a little risky, but the payoff is really big for students. Thinking about this ahead of time will pay off. So now we're on to the fifth action, or supporting struggle. So what are some ways we can support struggle during lessons or in the moment? Often we dismiss struggle students experience as they're not knowing what they are doing or imagining they don't want to put effort into the task. But developing thinkers who persevere through struggle is important to think about what struggle is and how it manifests in the classroom. So Warschauer developed a productive struggle framework to classify student struggles. So here's an adaptation on this work. Students are often unable to get started because they are unsure of what the task is asking, because they're overwhelmed by the size of numbers, or they're just unable to represent the problem. Students might be unable to stay with a task as they don't know what to do next. They've tried all the strategies they know, or they just simply are not interested in the task. Classifying the types of struggle can reveal patterns on the types of struggle that are most frequent in a classroom. When we're armed with this information, we can be better positioned to plan for how students might struggle, measure students' capacity for struggle, and plan for how to respond that promotes healthy or productive struggle. So this can be simply done by a checklist. It doesn't have to be fancy. It can be done with a sticky note and some sticky notes and a clipboard. By keeping track of the frequency of when students experience struggle will be useful for you. So no need to do this every day or capture every time a student struggles. However, collecting data at a certain time or with a certain task will be worthwhile, as you'll have evidence of what might make your students become stuck. So how we respond to struggle in the moment has many implications. Warschauer also established a framework for the type of teacher responses to struggle. We can think of this in two camps. Is our response as teachers an effort to rescue students' efforts to arrive at an answer? Or is it to help prompt student thinking when they're stuck? The latter can be thought of rescuing their thinking. There are pros and cons to both. I'd suggest, though, as we teachers may tend to overuse the telling and providing direct guidance, so students' opportunities to think and make their own meaning of mathematics is minimized. We might say that these are less productive. Efforts to rescue thinking are more conducive to productive struggle and thus student learning. They often are transferable in that they prompt students to generate a strategy or approach that can be applied to new situations. So rescuing thinking is that in-the-moment instruction move that is intended to keep students on the trajectory towards the learning goal. So to prep the task, first we must prepare the task. Before launching a task, this involves taking a few moments to set the stage for struggle by reminding students that struggle is a natural part of learning. Not a long or complex reminder, but we should communicate that that the struggle students experience is not because they are incapable of learning. And this helps identify productive struggle strategies that students can use for handling situations of struggle. The more we remind our students, the more they will begin to internalize some of these strategies. One wouldn't go through this entire list, but possibly revisit one or two bullets every day. What can you do if you struggle today? Or what might you try if you get stuck? What can you try before asking me a question? It may feel as if these quick reminders become repetitive, and most likely they will be for you, but not for your students. It increases acceptance and usage of the more they hear about them and discuss them. So this is one of my favorite productive struggle moves, catch and release. With this move to support productive struggle, the task is launched and the students work independently or in small groups. The teacher circulates, making observations and asking questions. When the teacher takes note of someone being stuck or multiple students being stuck, we stop the whole class and ask a question. This is the catch part. The teacher holds a brief, large group discussion and then lets the students back to working on the problem, which is the release part. After then the class debriefs together. So I observed this in a kindergarten room recently. The students were practicing correct formation of numbers. The teacher noticed student strategies for forming eights were all over the place. So she called the students back to the rug and said, I noticed we're having a hard time making eights. Who can tell us what we should think about when we make an eight? The class had a brief discussion before she released them to go back to their desks to work. So a variation of this is that students work, teacher circulates, and then the teacher stops all work and asks, I noticed Kelly added and Colby subtracted. Which strategy makes more sense to you? This highlights the use of a strategy and that students need to choose the one that they could best relate to. Then the students can be sent back on their way to work. Another variation of catch and release is we talk about certain representations to get students thinking about the tools they might use. So by highlighting different tools, the group or groups are not able to get started, that we're not able to get started, have some choices to consider. And then here's a thinking pit stop per se. It sends a message that it's good to ask questions, or as a community, we learn and grow together. So there's many advantages to this catch and release model. It improves engagement, it promotes thinking, and it helps students become unstuck when they're in an impasse. But if we wait till the end of the time when students are done working, it might just be too late. Another productive struggle move is referrals. When your students come to a standstill, you can refer them to a resource that they might not use or come up with on their own. However, students need to know how to use this tool. Young students might not know how to write much on a KWS chart. A K stands for what I know about the problem. A W stands for what I am trying to solve, or what am I trying to, what am I trying to find out? And an S is what am I trying to solve? So I'd suggest, some young learners go through this process orally. They can refer to the poster with questions, but they don't necessarily need to write things down. It'll begin to develop some good habits when they start to ask themselves these questions. Older students, however, can jot down their thoughts on a pre-made KWS chart, or they might even start to make their own. Here are two examples from older students as they recorded information they wanted to have as they solved the problem and got them unstuck. We might also refer our students to charts that we have collaboratively made with the students. Many times students do not refer to these charts on their own. Younger students may not be able to read them. Older students can't see them or forget about them, or it may be because the charts were posted on the wall without engaging students in the creation of the posters. On the left, how do mathematicians understand math stories? It's in the middle. This grew over time in a first grade classroom. The chart on the far right shows for things when I am stuck in a younger classroom, where the chart on the far left shows maybe in a classroom of older students. Often teachers refer students to these charts. They go find the strategy they want to use to help them get unstuck. The poster should be reference tools, not solely decorations for our walls. And a note about these charts: students need to be a part of the process for them to develop ownership. If they're just posted on the wall without any conversation to help students understand what they are, it's likely our students are never going to notice them. So they'll become, like I said, classroom art per se, not tools for them when they are learning mathematics. Another productive struggle move is to help students navigate struggle is to think of an answer that I know has to be wrong. This move prompts students to think about their own thinking. So you might ask a student, what answer has to be wrong? How do you know it's wrong? Even young students, like kindergartners, can say, I know 0 has to be wrong for a simple addition problem. Another productive struggle move that's become pretty popular lately is removing the numbers. By simply taking numbers out, students can focus their efforts on making sense of the problem. So I've shared many productive struggle moves that a teacher can employ. So be mindful of these as we begin to use and reflect upon moments when you might wish you would have used one or more of them. So we're almost to the end. Sorry, it feels like lots of information. So this is the last action, number 6. How do we celebrate encourage struggle? It's important that closure of a lesson happens, even if it's for 60 seconds. And it's important to note that it doesn't always have to be about the content. Including reflection on struggle occasionally sends important messages to students. It communicates learning and doing math is more than applying a process and arriving at an answer. Reflecting on struggle reinforces struggle is valued, and it plays an important part of learning mathematics. It contributes to our learning communities as well. One way to reflect on struggle is the Goldilocks reflection. Students identify if math was too easy, too hard, or just right for them for the day. Whole group discussion, you can turn this into turn to a neighbor and share, write it in a journal, make a sticky note chart, or go to 3 corners of the room where these categories are listed. It's important that these conversations take place prior to having students identify this on their own. What does it mean that too hard or just right mean? Then they can really truly reflect. We might also revisit those productive struggle pictures and ask students to make analogies. Today, math was like the ducks because it felt like everyone was watching me when I was struggling, or the elephant because I didn't think I could keep doing it, but I kept trying. The rock climber because I used tools to help me when I got stuck. It may be that a conversation is prompted by conversation starters. It's okay not to quit. Today, I didn't quit when blank, and have students just orally and think about, or maybe they might personally reflect on these or orally share, or even maybe write them in a journal. Older students might choose one word which best defines their math experience for the day. Here are some examples of what students came up with for this type of reflection activity. So we've got to reflect upon struggle and also celebrate struggle. I know that kids and students love getting recognized for a job well done. So we might give a student a shout out that they can take home, or a struggle buck that students can cash in for a prize after a determined number have been collected. We might also have a traveling trophy per se. I know that one's a little cheesy, but it gets to sit on the desk and who worked really hard to navigate struggle for the day. Recognizes that student for working through their struggles. I know young students really like stickers or bag tags that serve as a, hey mom, look what I did in school today. I'm a struggle star. Just a simple sticker will invite conversations at home and why a student receives such praise. So having conversations with families right out of the chute will help them see the value in struggle and that they can celebrate with their child too when they see such recognition come home. We went through these 6 actions really quickly, and as I anticipated, there's only about 3 minutes left, and so I don't think we'll get to have breakout rooms. So I suggest these 6 actions promote productive struggle in classrooms. We value struggle. We have to foster identity, build community, plan for struggle, support struggle, and reflect on struggle. So what's one idea that resonates with you? Take just a second to think about that. All right. So I know, again, we went through this really quickly, and I just want to thank you so much for spending time with us tonight as part of this Nebraska Math Circle. I hope you got a small taste of the 6 actions, and hopefully you're thinking a little bit more deeply about productive struggle in your own classroom. Remember, and I just want to leave you with, remember, math rocks, especially when there's productive struggle. So a couple of different things as before we go. I did notice in the chat somebody asked about slides, and I will work with Lindsay and Stephanie, and we can make those available for those of you who joined us tonight. So I know I went through those really fast, and I apologize. And I know if you'd like that information, we will get that to you. The other thing is please feel free. My email is listed there, and feel free to reach out to me if you have any questions or you want to chat more about this whole idea of struggle. It's something I've really, the more I dive in, the more interested I am, and I love to have conversations with any and all of you. So please let me know. Couple different things. And I also understand that the first 25 people who registered and attend, we're going to receive a free book, which is really exciting. So Lindsay from the center is going to be working on that tonight and tomorrow and getting those books to the lucky recipients very soon. So you can watch for that. The other thing, and this is not a sales pitch, so I want to preface it as that, but if you're interested in the book, and you aren't one of those lucky people, I'm going to give you a little tidbit. If you go to the Corwin website, the book is about, let me do some math, $4, $5, $6, $7 cheaper than it would be on Amazon. So there's a discounted price on Corwin. So if you're interested, that might be something that you can go check out. But thank you again so much. It was so great. Like I said, I wish I could see all your faces in person. I can only see a few of you at a time, but it was great to see lots of math friends throughout the state, and I just really appreciate you being here tonight, especially on a Thursday night after probably a long few days after winter break. So thanks so much and appreciate it. And let me know if I can ever chat or talk more about productive struggle with you. Thanks so much, guys. And I'll stay on if anybody wants to chat or ask questions. So please let me know.
Thank you, Susie. One quick housekeeping thing. We have Anne who just listed a first name. So Anne, if you can direct message me with your last name, that way I will know if you are in the running for that book.
Awesome. All right. Thanks, everybody.